Our focus for today's lesson is going to be looking at divisibility rules. And so, divisibility rules are a set of ways or tips and tricks that I can use to figure out really quickly if one number is divisible by another number. So when we take a look at these really large values, this one like 55 we could look at and pretty easily determine what the divisibility is going to be. But when I look at 569,820, I may not know what that's divisible by. So I have some strategies that I can use to help me to determine what this number is going to be divisible by. So you have your graphic organizer or note catcher that talks about the different divisibility rules. And so we're going to just go through and I'm just going to add in the rules for a number and then we'll go through and we'll do some practicing. So a number is divisible by 2 if it is an even number. And so an even number we're looking at, it ends in 0, 2, 4, 6, or 8. If it ends in those values, it is going to be an even number. A number is going to be divisible by 3 if the sum of the digits is a factor of 3. So what I do here is I'm going to add the digits together and see what I get. When we take a look at the rules for 4, if the last 2 digits are divisible by 4. So if I have a large number, I'm only having to look at the last 2 digits. For 5, it's going to be divisible by 5 if it ends in 5 or 0. That's a really quick one. I'm hoping you guys look at that and go, I already knew that. That's probably the most simplest one along with the 2. Is some of these you just have to look at, and then others you have to do a little bit of things. It's going to be divisible by 6 if it is divisible by 2 and 3. So you need to have it divisible by both 2 and 3. If it's divisible by 2, but not divisible by 3, then it's not divisible by 6. When we take a look at the divisibility rule of 7, 7's a wonky rule, and sometimes it's just going to be easier to divide it out, but we'll at least go through so you have it. You're going to take the last digit of the number, double it, then subtract the result, or subtract the doubling from the rest of the number. If the new number is evenly divisible by 7, so is the original number. So we'll take a look at this one as we go through, because again, this one is one of 2 divisibility rules that is going to be the funkiest of the divisibility rules. So 8, a number is going to be divisible by 8 if the last 3 digits are divisible by 8. So when we looked at 4, we looked at the last 2 digits. For the last 3 digits, we're going to just look and see if it's divisible by 8. So we just are going to divide out 3 values instead of 6 values. For 9, you are going to do the same rule as 3. If the sum of the digits is a multiple of 9. So when we looked at 3, it had to be a multiple of 3. When we look at 9, it has to be a multiple of 9. 10, if it ends in 0. That is how it's going to be divisible by 10. Okay, if we take a look at 11, 11's my other wonky rule. So add the numbers in even places. Then you're going to add the numbers in odd places. So every other number. So I'm going to add every other number for even, add every other number for odd. And then I'm going to subtract. And if the difference is a multiple of 11, then the number is divisible by 11. And then 12, my last little rule for 12, is going to be very similar to 6, only except it needs to be divisible by 3 and 4. So if it's divisible by 4 but not by 3, it's not going to be divisible by 12. So go ahead and pause the video, go back, add any of the notes that you need to add into, and then we will work on the next part of our lesson. So the next part of our lesson is going to be actually going through and checking our divisibility rules for some of these. So we're going to just look and see if it's going to be divisible by some of the divisibility rules just by using those rules that I just gave you. So if we take a look at number 1, and you guys have this on your worksheet, so go ahead and circle as we go through and do the problems with me. If we take a look at number 1 is 3,642. And so I'm just going to go through and I'm going to work through the different values here and see what we end up with. So 3,642, I'm going to add the sum. I'm going to add the digits. So I'm going to add 3 plus 6. So I'm just going to do this off to the side so you can see 3 plus 6 plus 4 plus 2. Now when I add 3 plus 6 plus 4 plus 2, I get 15. 15 is a multiple of 3. So it's going to be divisible by 3. Then the next value that I take a look at is I take a look at 4. And so for 4, I look at the last 2 digits, which is 42. And I look at that and I say, can 42 go into 4 evenly? And the answer is no. So it's not divisible by 4. It doesn't end in 5, so it's not divisible by 5. 6, we need to check. It doesn't have 2 on my value, but I need to see, is it an even number? Yes, it ends in 2, so it's an even number. So if it's divisible by both 2 and 3, that means it's divisible by 6. And then my rule for 12, it's divisible by 3, but not by 4. So therefore, it's not divisible by 12. Okay, if we take a look at 516, so when I look at 516, I'm just going to go through and see what my rule is going to be. Look at 516, the first rule I'm going to look at is 2. So I look and I see, does it end in an even number? My answer is yes, so it is divisible by 2. I'm going to add the sum of my digits together. So I'm going to add 5 plus 1 plus 6. And when I add 5 plus 1, I get 6. Plus 6 is going to be 12. So it is divisible by 3. And then I look here at my 4. The last 2 digits is 16. So it's divisible by 4. If you take a look, if you recall, when I added my sum of my digits, I get 5 plus 1, which is 6, plus 6 is 12. 12 is not a multiple of 9, so it's not divisible by 9. And it doesn't end in 0, so it's not divisible by 10. Okay, let's take a look at this large number. So I'm going to just go by the ones that I can see visually first, and then I'll worry about the ones where I have to do a little strategy. So I look at the last value. The last value is a 0, which means it's divisible by 2, by 4, and by 10. Sorry, not by 4, by 5. To look at 4, I have the last 2 values of 20, so it's going to be divisible by 4 because 20 is a multiple of 4. And then for 3, I need to add up the values of the digits and see. So I'm going to add 5 plus 6 plus 9 plus 8 plus 2 plus 0. So 8 plus 2 is going to be 10. 10 plus 5 is 15, plus 6 is 21, plus 9 is going to be 30. So 30 is a multiple of 3, so it's divisible by 3. All right, we take a look at 55. 55 doesn't end in a 2-digit number, or it doesn't end in an even number. It's not a multiple of 4. It ends in a 5, so it's divisible by 5. And then if I take the last rule and look at it, it's a small fact, but it works. I can try it for 7. So if I take the last digit, it would be 5. Double it, it would be 10. And if I subtracted 10 from 5, I'd get negative 5. So it's not divisible by 7. And then I don't need to use the divisibility rule of 11 here because I can just recognize that 55 is a multiple of 11. So it's divisible by 5 and by 11. Okay, if we take a look at 48,704, take a look at the ones I can do first. So I have 4, so it's divisible by 2. The last 2 digits is 4, so it's divisible by 4. And then I have to look at 3 and 9 because 8 is going to require me to do some multiplication or some division. So I'm going to wait on that one. And I'm going to go ahead and I'm going to solve. So I'm going to add them. So 4 plus 8 is going to be 12. Plus 7 is going to be 19. Plus 4 is going to be 23. So it's not divisible by 3 or divisible by 9. So I'm just going to divide this out by 8 really quickly and see if it's going to be divisible by 8. So 8, notice I didn't do 48,000. I just did the last 3 digits. 8's going to go into 78 times. 8 times 8, 64. I'm going to subtract. I'm left with 6 left over. I bring down 4. 8 goes into 64 8 times. I'm going to subtract. So this value is divisible by 8. Look at number 6. So first thing I'm going to take a look at is I don't have any one that's a visual only. So I'm going to add up the sum of my digits first. So 9 plus 5 is going to be 13. Plus 1 is going to be 14. Plus 4 is going to be 18. So 18 is a multiple of 3, and it's a multiple of 9. So it's divisible by 3 and by 9. And then I'm going to take a look at 12. So if you recall the rule for 12, it has to be divisible by both 3 and 4. So I'm going to look at the last 2 digits. It's 41. 41 is not divisible by 4, so it's not divisible by 12. And then we're going to take a look at this last one. And I'm going to go ahead and do the same thing where I'm going to do 8, and I'm going to divide 541 into 8. 8 is going to go into 54. So 8 times 6 is going to be 48. I'm going to subtract. I'm left with 61. 8 goes to 61 7 times. That's 56. And I have a remainder of 5. So it's not divisible by 8. Now we need to take a look at the divisibility rule for 7. And we look at the divisibility rule for 7. I'm going to take the last digit. I'm going to double it. So I have 954 subtract 2. And when I do 954 and I subtract 2 from that, I'm going to get 952. And now in this case, the rule didn't really help me all that much because it is a large number. So I need to see, again, that doesn't tell me whether or not it's divisible by 7. So I'm just going to have to go ahead and I'm going to have to divide out 9,541 divided by 7. So I'm going to let you guys go ahead and do that while I make some workspace, and then we'll see if our answers match up. Take a look at the work that I ended up with. It ended up being divisible out, so it is going to be divisible by 7. Now you'll notice that the 3 and the 9 disappeared because I caught myself when I took a look back at this and went, hey, wait a second, 9 plus 5 is not 13, it's 14. So 14 plus 4 is going to be 18 plus 1 is going to be 19, so it's not divisible by 3 or 9. And just the way that this works, they disappear out when I have to erase. Okay, so if we take a look at number 7, we have 21,208. So looking at the last values, it's going to be divisible by 2, divisible by 8. It's not going to be divisible by 10, so that's going to get crossed off. Sorry, not 8, 4. I have to divide it out to see if it's divisible by 8. So let me make some workspace and then we'll check to see what it's going to be divisible by. If it's divisible by 8. Work that 8 is able to go into 208. So 21,208 is divisible by 8. Now we're going to take a look at 11 and see what that wonky rule says in terms of checking for divisibility. Divisibility rule for 11. And when I did that, you'll notice that I broke the values up. So I did every other number. So 2 plus 2 plus 8 is going to be equal to 12. And then 1 plus 0 is going to be equal to 1. And when I subtract that, I get 11. 11 is a multiple of 11. So 21,208 is going to be divisible by 11. At this point in time, you guys are going to finish the rest of this page and then working on your packet that you have. Bring the packet when you come to group, and we'll spend some more time talking about divisibility.